This is chapter 14, Chemical Kinetics, and it is one of my favorite chapters. In fact, all of the chapters in Chemistry 1220 are my favorites. They describe real-life chemistry. So what is kinetics? Kinetics is really all about rates. It's all about speeds of reactions. Think about how your car can go different miles per hour. Well, chemical reactions can also have different speeds. So what we have here are some examples. Methyl bromide, it is used to treat fungus, and what it can do is go up into the atmosphere and destroy the ozone layer. So people want to know, how does this break down? I also learned that it's very poisonous. Over here we have the catalytic converter for your car. So anything that is not fully combusted to CO2 and water, a la chapter 2 or 3 in Chemistry 1210, it makes harmless gases like, well, not harmless, CO2 and N2. Finally, on the bottom, we have the big one, nitrogenase. Nitrogenase is a metalloenzyme that's found on the roots of different plants. And again, when we talk about enzymes, we're talking about the end of the chapter. But its cofactor is part of the impossible burger. So what do we have here? Well, chemists love to do experiments, and what they do is that helps them devise some theories that helps them better understand how a reaction occurs. There's 3 different levels. I like to talk about it this way about how we use them. Number 1 covers section 14.2 to 14.3, and it has to do with synthetic procedures for practical purposes. You want to make money if you're operating a manufacturing facility. The second one, it is really used to deduce what we call a molecular description. What's really happening on the molecular level, and we cover that in section 14.5. And then in section 3, we really try to understand how individual transformations occur. Now, remember, this is an intro course. There's a lot more information. We do not go into depth, but this is to give you an idea of where kinetics play a role. Zewail received the Nobel Prize in 1999, and they call him the father of femtochemistry. Why is that? Well, he looked at processes that occur on the order of 10 to the minus 15 seconds. Very, very quick. So essentially what he did is he used one laser to start a reaction, and I'll just say the other laser to take a picture. It's a very basic way of describing it. There were no direct images, but from the optical properties, he could deduce what was going on the molecular level. Finally, this is section 14.1. What are the factors that affect reaction rates? There are 4 of them. The first one is, what is the physical state of the reactant? Think about a tablet, think about a fine powder. I think that's a good way to think about that one. The second is, think about the reactant concentration. Often you'll say, hey, it's faster if I have more. Well, we shall see as we go through the chapter. The third factor would be temperature. And think about bacteria in milk. They normally are there. We refrigerate it to keep the bacteria from growing so the milk does not spoil. But if you leave milk out on a hot summer day in a couple of hours, you're simply not going to want to drink it. And that's the role temperature plays with bacteria reaction. Finally, catalysis present. And I think that is the last section. You learn all about the mechanics of kinetics, but really where you're going to encounter them, we do that right now. The enzymes in our body, the proteins, all these different factors, and it's all lumped into this chapter called kinetics. So on the molecular level, because again, we are Gen Chem, we're going to talk about how frequently something collides. Think of 2 cars on an icy road. No, we shouldn't think that, okay? The greater the frequency, what we will find is the higher reaction rate. There are a lot of other factors, but we'll consider each of them individually. And the thing I want to leave you with, all of these rates span enormous time scales. We have our femtosecond reactions, 10 to the minus 15. Of course, we have our explosions. Then we have rusting. And finally, the erosion of rock and things like that. So I find it to be a very exciting chapter. But again, you know that I find odd things exciting. So please come to Zoom lecture. I can expand on these things more and probably give you a little bit more insight.